Hi again. In this video I will show you how to solve assignment problem in example 8.7 in chapter 8. Before we start, please make sure you have the right file. Now let's get familiar with the data we have. So here we have a company called Fleam Boot, and they import boots from all over the world and ship them to major retail customers in the United States. Fleam currently has 3 assortment warehouses in the cities of Atlanta, Fort Worth, and Tucson. And then on the other hand, from the demand side, they have 4 major customers, which are Billy Bob, Dudewear, Slickers, and CJ's. The weekly capacities for the warehouses and weekly demands for the customers are shown here. So here we have the capacity, and here we have the demand. Actually, let's calculate the totals here, just to see our total capacity against our demand. Type sum and select days, and then again sum and days. So we have 90k capacity against 82.3, which is I guess okay. And down here we have our shipping costs, meaning cost to ship one pair of boots from warehouse to customer. So for example, if you want to send a pair from Atlanta to Billy Bob, it's gonna cost you $2. But if you want to send the same boot from Atlanta to CJ's, it's gonna cost you $1.50. And from Tucson to CJ's, it's gonna cost you $3. So the challenge here is, given the different shipping costs, which warehouse should serve which customers in order to minimize our logistics costs. And we're going to use this table here to do our dispatch allocations. Now you can do it manually if you want, but it will take you quite a amount of time. And for that reason, we're going to use Solver. But before, we need to set up some formulas so that we can tell Solver our objective. First of all, we need to have some formulas here. And here. This will help us to see total dispatch from a warehouse and order allocation to a particular customer. For example, if I will allocate 10,000 from Atlanta to Dudewear, here I will see total dispatch for Atlanta, and here I will see total allocation for this customer. If I will allocate another 10,000 from Atlanta to CJ's, here I will have total of 20,000. And now I can actually see that I have reached my capacity limit for this warehouse. Now, if we look at our slide, we will see that our optimization formula looks like this. What it says here is that we have to multiply the number of units shipped from each warehouse to each customer to the cost of shipping units from each warehouse to each customer, respectively. And while doing this, we have to consider these constraints. First, we cannot dispatch more than our capacity in a particular warehouse. Second is that we have to at least meet the demand for each customer. And finally, obviously, our numbers should be positive. If you want, you can of course do this manually, but it will probably take you too long. And that's why we're going to use Solver for this. It means Solver will help us to find ideal number of units to be shipped from warehouses to customers with minimum cost. So in Excel, Solver will populate this area for us. Come back to our file. Now, in fact, before running Solver, we need to set up this formula in Excel so that Solver can refer to it. Come here and type sum product and select this area, then comma or semicolon, depending on your Excel settings. And select this area, then close the brackets and enter. What this formula will do is that it will multiply each cell from here to here and add them all together. Right now it shows nothing because we don't have any data here. Now we are ready to run our Solver. Come to Data and select Solver. In this new pop-up screen, we have to set up some rules. Our target cell is this one here, where we have the formula actually. And then select minimum here, because we want to have the minimum cost. By changing cells, we select this area. As said earlier, Solver will populate here. And finally, we need to add some constraints, or limitations if you want. Number one is, we don't want to see any negative number here, because logically it's not possible to sell negative number of products. This area must be greater or equal than 0. Second, we don't want to dispatch more than we are capable of. First we select total dispatch for Atlanta, and it must be less or equal than the capacity of Atlanta. Same for Fort Worth and Tucson. Next, we have to add constraints for customers, meaning that we must at least allocate the requirement demand for them. The sum or allocation for Billy Bob must be greater or equal to Billy Bob's demand. Same for Dudeware, Sleekers, and finally CJ's. Now we are ready to run it. So our solver here shows that if we do this allocation, we will have the minimum cost of this amount. By the way, don't worry if you get such numbers here. It's just scientific numbers for 0. Not sure why Excel does it.